Students, today we're going to go through section 6.1. Chapter 6 and beyond will introduce you to different types of distributions. So we're going to be covering a whole bunch of them, of distributions that are used in the real life situations. So and I'll explain to you how each of them is used in the real world. So we begin with the first one. The first one is called the uniform distribution. So the uniform distribution has unique features. Okay, let me show you in the book. So the major focus of this chapter is to go through the main part, which is the normal distribution, but the uniform is a little bit more of an introduction to how the normal distribution works. So the uniform distribution, the area under the graph, recall that there were two conditions. Remember the two rules for a probability distribution? It's the same thing. Remember, the sum of the P of X had to equal to 1. And each of those P of X values had to be between 0 and 1. Well, for the uniform distribution, we're talking about areas. So the area of the graph has to equal to 1. And the probability of all of the, all of the events has to be a value between 0 and 1. So it so happens that the graph ends up looking like a geometric figure. So let me show you what it looks like. Right, so the graph of it right, so recall when you all took math, when you all did plotting points on a line, you had a Cartesian coordinate system. You had the positives, and then over here you had the negatives, and you had below. So you had your y-axis that goes down, and your x-axis went this way, right? Well, we're only concentrating on the positive quadrant, this part of the quadrant. So this scale here, it represents the x, and this scale here represents the P of X. Okay, and the graph of it begins here at the origin, and so we call it the initial. That's the initial point. And over here at the end is called the terminal. Right, so we label it A is your initial, B is the terminal. So graphically, the shape of the graph goes like this. Okay. So it's rectangular. The graph of it's supposed to be a rectangle, but it's crooked. But anyways, it's supposed to be a rectangle. So our goal is to figure out the area. Area is how much inside is covered up. That's what our goal is going to be when we find probabilities with the uniform distribution. And so most of the time, the P of X value, the probability, will be given to you, and that measures this side. This is this height or the width. Right? So if they do not provide you with the P of X, which they will, but if they don't, here's the formula that they use. Formula is 1 over parentheses terminal minus the initial. That's what the formula would be if they do not provide you with the P of X value. So as you recall, again, it had to fulfill the requirements. So for a probability distribution, so the area inside this rectangle has to be equal to 1. So here are the rules, right? Must pass. Again, the area must equal to 1, and the P of X value, and we wrote it as a compound inequality, right? 0 less than or equal to P of X less than or equal to 1. Right, so that means the P of X, as you recall, P of X must be a value between 0 and 1. And the area, since we're dealing with the area of a rectangle, the area of a rectangle was area equals length times width. Okay, so you have to use that formula to determine if that shape is going to equal 1. So the length is considered from the initial to the terminal. This is the length. That part right there is the length. And the distance from the bottom corner to the top would be your width. So your width is always whatever the P of X number is. That's your width. It's always equal to your P of X. Okay. All right. So let's do an example of a uniform distribution to make sure to see if it passes both of those conditions. Okay. So in the book, they talk about wait times for airports, I believe, plane wait times. I can read it to you. So it says that, find it. It is the very first example. Book. Find it. Okay, it's right here. Wait times for airport security. Okay, so example 1, it says, during certain time periods at JFK Airport in New York City, passengers arriving at the security checkpoints have waiting times that are uniformly distributed between 0 minutes and 5 minutes, as illustrated in the next page. All right, so you have this. So there's your at the time. Time and or intervals that are used in real life. That's a situation that requires the uniform. Anything dealing with time or intervals used, that's when you know uniform is the distribution that you use. So we know that the waiting times, you have to wait, people have to wait from between 0 and 5 minutes. So there's your initial and there's your terminal. Okay, so let me draw the picture. So this is what we have. And you're gonna have to draw. You're gonna have to draw these just like me, so you can get the hang of it. All right. So here's our graph, right? So we know that the initial was 0 minutes, and our terminal is 5 minutes. Minutes. Supposed to be 5. Okay. And we draw a rectangle because we're dealing with time. Okay. And let's see what it says for our P of X. So in the book, it says, we are going to be assigning a probability of 0.2 to the height of the vertical line. So that's what the height is. So your P of X is equal to 0.2. 0.2. Okay. So what if they didn't tell us? Well, let's see if that formula works that I gave you. So if I had used the formula, if they had not given me the p of x, and I had not given, was not given the 0.2, let's see if it works. So it was, the formula was 1 over b minus a, right? So there's my b is 5. So it's 1 over parentheses 5 terminal minus initial 0. And you will see that it ends up being 1/5, which is equal to 0.2. So the formula does prove that it works. Okay, so there's our graph. Okay. And I want to see if this graph fulfills the requirements. All right, so let's see if they pass. Let's see, rule number 1. All right. Number 1, my area has to equal to 1. Okay, area has to equal to 1. So I'm going to use my formula. A equals L times W. A equals L times W. All right, so I got to figure out my length. So to figure out the length, all you have to do is, again, you're going to do terminal minus initial. That's the formula for the length. That whole thing, this whole thing is the length times the width. Right? My width is this part, which is my p of x. So I'm going to plug them in. I'm going to do terminal. It's 5, 0, wrong color, times my p of x which was 0.2. I know that that's going to be 5 times 0.2, and you will see that that equals to 1. Ching. So rule number 1 passes. Number 2, I need to see if the p of x value is a number between 0 and 1. So is this true? Is 0.2 a number between 0 and 1? Yes, it is. It's negative nor a above 1, so it is. Good. So it passes. So our graph passes our rules. Okay, so I'm going to put a little note. When do I know that a real life situation involves the uniform distribution? Right? When you're given, if time is a factor, or your intervals, and you're thinking, well, what do you mean by intervals? Say like your car battery, your voltage, gas gauge, anything that has a start and finish is considered to be a uniform distribution. Okay. All right, so once you know that your uniform distribution passes two rules, your uniform distribution is ready to roll. So once you have that taken care of, all right, I'm going to draw it again. Okay, I'm going to draw my picture again. Zero minutes. 5 minutes. I put C. Caught myself this time. Okay. Draw my rectangle. That was a better one, Mr. Guerra. Very good. And my P of X is 0.2. You can once it passes the two requirements, you can subdivide the picture or the graph or the rectangle into pieces if you want. So I'm going to split it up. And I'm going to label it 1 minute, 2 minutes, 3 minutes, 4 minutes. We can divide it out. And then once you do that, you can figure out the probabilities. And you got to remember, to figure out the probabilities, you're going to use the formula, length times width, the area. All right, so suppose they ask you to find the probability that the wait time is less than 3 minutes. Okay, so less than 3 minutes. So you're going to go to your graph and you're going to shade the regions where it is less than 3. So do I shade to the left of 3 or do I shade to the right of 3? It says less than. That is correct. I'm going to shade to the left. Less than. So I'm going to shade I thought I would have a highlighter, but I don't want to have highlighters. So I'm going to have to wing it. And so I want to find the probability or the area within the green. Okay, so let's use my area formula. Area equals length times width. All right, so I know my length again was terminal minus the initial. And my width was my P of X. It's that, and this is the length. All right. And now when you do your terminal minus initial, you're not doing the complete box. You're only doing the regions that are in the green. So here's my initial still at 0, but now my terminal is now at 3. I only want the green part, not all of it. That's why 0 is the initial, 3 is the terminal. So it would be 3 minus 0, keep forgetting, times 0.2. That's equal to 3 times 0.2 equals to 0.6. Now, for those of you that are visual learners, okay, you can do it a different way, okay? So visually, you can do it like this. So you can use the definition of a fraction, right? Or probability. What was the probability? parts over total. Remember, we talked about probability? It's parts over total. Well, how many total parts do I have in my rectangle? Well, there's 1, 2, 3, 4, 5. There's 5 total parts. And how many are shaded? There are 3. If I divide 3 by 5, guess what you get? You get 0.6. Interesting. So less than, shade left. Okay, you gotta remember that. Less than means shade left. Okay. I'm gonna draw the picture again. And this time I remembered. Okay. P of x 0.2. Divide it out. One minute, 2 minutes, 3 minutes, 4 minutes. Bad habit I have. Very bad habit. Okay. All right. Same picture. This time I'm asked to find the probability that the wait time is greater than 4 minutes. Okay, greater than 4 minutes. All right, so which region do I shade? Do I shade to the left of 4 or to the right of 4? It's greater than. That's right. I need to shade to the right of number 4. So you're shading to the right. Shade right. So less than, shade left, greater than, shade right. And I use my infamous area formula, length times width, where length is terminal minus initial, and my P of X is my width. Right, and so when you do the length, and remember you gotta get two new, now you got two different initial and terminals than the previous one, right? So your initial now, your initial is 4 and your terminal is 5. So it'll be 5 minus 4. There's a 5, there's a 4 times the P of X. Yes, someone's saying, hey, wait a minute, the P of X number never changes. That's correct. It is constant. It never changes for this particular problem. For other problems, it would be a different number, but just for this one, it's just standard. It's still set. So this would be 1 times 0.2, and you get 0.2. Again, if you're visual learners, parts is 5. I have 1, 2, 3, 4, 5 parts, and how many are shaded? Only one region shaded. Well, if you guys do divide 1 by 5, you get 0.2. Nice. All right, so we got less than, we got greater than. There's one more. So guess what? I have to draw the picture again one more time. So let me draw it again. You can see it. I guess I can duplicate it. I'm not. I'm gonna just do it. I'm not that easy. keep going over. 1 minute, 2 minutes, 3 minutes, 4 minutes. Okay. Oh, got to label my p of x. X equals 0.2. Like that. And I'm asked to find the probability that the wait time is between 1 minute and 4 minutes. Right? Between. What is in between? What is between? Well, between means it's between. So you're at 1 and 4. You got a shade in between. You got to shade these regions in between the 1 and the 4. So there's the in between. Didn't do well in grade school when I colored. But anyways, there you go. There's your in between. So how do I find the area? Area equals length times width, where length is terminal minus initial times my p of x. Right? So I'm only, remember, the length is the start and finish of the green section, right? So there's your initial and your terminal. So it's 4 minus 1. 4 minus 1 times 0.2. You get 3 times 0.2. You get 0.6. Again, there's 3 shaded out of 5. Then you can see that it works. So you got to recall, less you shade left, right you shade greater. Greater is right, and in between is between. So less is left, greater is right, in between is in between. So you really don't need to have these sections off. You really don't. So as another example, let's give you an example. Suppose that we have our graph again. I'm going to draw it one more time and that's it. But this time I'm not going to subdivide it. I'm not going to divide it into pieces. Oh, I caught myself again. Minutes. Okay. P of x is 0.2. All right. I already tested it and all that. Right. I don't need to subdivide it. And suppose that you're asked to find me the probability that the wait time, and it doesn't even have to be a whole number. Wait time is less than 2.75 minutes. 2.75. Okay, well, you're like, well, what do I do? All right, so you're going to plot 2.75. You know it's between 0 and 5, and you're going to have to wing it. Guess, where would 2.75 be? I'm going to just take a wild guess. I'm going to just say right there. 2.75. Okay, more or less. Now, you got to remember, the key word is less. Do I shade right or do I shade left? Less is left. So I need to shade to the left. Now this one you won't be able to use the parts over total. You're gonna have to use the area formula. So again, area equals length times width, terminal minus initial times P of X. So there's my initial, there's my terminal, so it'll be 2.75. Someone's asking me, what happens if I reverse them? Well, you're gonna get a negative. You can't have negative probabilities. So you have to do, the bigger number goes to the left, the smaller number goes to the right. So 2.75 minus 0 times 0 0.2, 2.75 times 0 0.2. Now I'm going to need my calculator on this one. So I get 2.75 times 2 is 0.2. 2.75 times 0.2 is 0.55. So you really didn't need to section off in pieces. You just have to be able to recall terms less than the shading. Less is left, greater is right, in between's in the middle. Okay. All right, so now you can do your homework. You can do the exercises in the book. I think there's like 4 of them. I think it's 5, 6, 7, 8. Just to get you refreshed with the terms less than, greater than, in between. Okay, so that's the concept of the uniform distribution. And now we go to the normal distribution, the bell shape. So for the bell shape, now we're really going to get into more into the bell shape. Okay, so this is the standard normal distribution. Okay, so you had your bell shape. And I'll tell you what makes this graph so unique. All right, so the scale, this bottom scale of the graph is the z-score. Think of the z-score that we did back in chapter 3. Remember we did the heights of people, right? Think of the z-score like the number line. You had 0, you had the next. So in the middle, it starts at 0. Why does it start at a 0? Because what makes this graph so unique, this distribution so unique, is that the mean is centered at 0. That's your mean. The mean is right smack in the middle. And the standard deviation is 1. What does that mean? That means, how do the increments go as I go along to the right and to the left? So it goes in increments of 1. So recall that 0, the values on the right of 0 are positive. So it goes 1, 2, 3, 4. And then I go the other way. So it would be -1, -2, -3, -4, and so on. Right? Now, if this had been a 2, then these would go 2, 4, 6, 8. So the increments is decided by the standard deviation. So that's what makes the standard normal a standard normal, is because it has a unique feature that the mean is always at 0, standard deviation is at 1. So what we're going to do now is we're going to do the same thing that we did on the uniform distribution. We're going to figure out the area within the graph, given a z-score value. That's what we're going to do. So there's going, just like we did the uniform, there were 3 of them. We had less than, we had greater than, we had in between. Same thing happens with these. Okay, so we're going to be drawing a whole bunch of these. I'm going to show you how to do these. Now, in the uniform, we could do it by hand. For the standard normal, we're going to have to use statics to figure out the areas for us. It'll compute it for us. You can use a table in the back of the book. It's table A2. If you want to learn how to do it the long way, I suggest that you read the textbook. It'll show you how to read the values from that table, and you can figure out the areas. So the handout that I provided you all with on our modules under StatDis notes, I have the instructions on how to do it manually and how to do it with StatDisk. So if you're going to do it manually, again, you're going to have to use area, the table A2 in the back, and it'll tell you how to do it. So here are the instructions here. They're all right there. Okay. But if you're going to use StatDisk, all right, you're going to use StatDisk, you would go to the second page and it'll give you all the instructions on how to use StatDisk. So you would have to go to page 2 in our handout and it'll tell you how to find the areas. And I have it written here for you all, for you to see. All right, so, and I'll show you how to use it in a minute. Okay, so let me show you first the 3 probabilities that you're going to be asked to find. Okay, so first one, I'm going to draw the picture. Eventually, I'll get really good at drawing these normal curves. All right. So the first one goes like this. So the way they write probabilities is they write it as probability of Z. They put Z because that's a Z score. That's a Z scale. Less than, and we're going to use A as a guide. Okay. So in the middle again is 0. Okay, so you have to keep track of the sign of the value A. It can be any number. It can be positive or negative. It depends. If it's negative, you're going to plot it on the left of 0. If A is positive, you're going to plot it on the right of 0. Okay, you can more or less, guesstimate where it belongs. All right, so let's just say, for example, A is positive. So you plot your A, you draw the line, and because it's less than, we're going to shade. As you recall from the uniform, we would shade to the left. Shade to the left. Okay, that's the first one. Okay, number 2, I'm going to draw another picture. See if I can draw it. Put 0 here. And another probability they could ask you is to find the probability Z greater than A, or B. Would you use B or use A? Probability of, again, it depends on what the sign of B is. If it's negative, you plot it on the left, positive on the right. Let's just say, for our sake here, that B is negative, right? So you plot B there, it's negative. And it's greater than. As you recall, greater than, from the uniform, you shade to the right. And I'm gonna underline the word right, and the other one I'm gonna underline the word left. Okay, keywords. Draw the shade left. Yeah, someone asking me, it looks like a snail. Yes, it does. I've never eaten one, and I think I will never will eat. All right, so there's less than. Oh, I didn't write it down. This is less than. Forgot. Less than. Right, less than. You can write it down. This is the greater than symbol. Greater than, less than, greater than. And then the third one, as you recall from our uniform distribution, we had the in-between. Sorry, it's a sound. 0, 0. So you would write the probability for the in-between would be probability, and it's written in compound inequality format. So you put, it's written as A, you put the smaller number on the left, and you put the Z, and then you put the bigger number on the left. I'm sorry, on the right. The smaller number on the left, bigger number on the right. Small, big. It's always like the number line. The numbers on the left are always smaller than the ones on the right. So here is, you're going to plot A. Let's just say A is negative and B is positive. And so you would shade in between. It's the between. And this is shade in between. Okay. So you will have to, on the homework, you will have to draw the picture, plot the point, shade the area, and then find the probability. Okay. You will have to do that. Okay, so now we're ready. So let's practice. Okay, so let's practice with the ones in the book. All right, so in the book, they have some pictures already drawn for you. There you go. Bam. Okay, so let's look at number 9. Okay, number 9 on page, what page is it on? 240. Right, number 9. This is find the area of the shaded region. Okay, so number 9, you have your Z, and notice it doesn't have 0 in the middle. It should, but it doesn't. All right, so how do I write the probability for number 9? So the way you write it is you write capital P, parentheses, and you put Z, and now you got to remember, which inequality do I use? Which way is it shaded? Is it shading to the left of 0.44 or to the right of 0.44? It's shaded to the left. So that means it is going to be a less than. Less than is left. So you're going to write capital P parentheses Z is less than 0.44. So this is how you're the correct way of writing a probability in standard normal terms. This is how you write it. Okay. And now I'm going to go to my stat disk and I'm going to have it calculate the area for that. So I'm going to have to draw it. If you have to draw it, I'll have to draw it as well. So here's the graph of it. Just a little baby one, right? All right, 0.44 is positive, so it has to be right here. 0.44. I'm really exaggerating it. And it's shading to the left. So my goal is to figure out how much shading is done on the green. That part. That's our goal. Okay, so let's go to StatDisk and I'll show you the steps. So let me see if I can find it. Here it is. Okay, so on StatDisk, you're going to go to the tab at the top, Analysis. You're going to click on Probability Distribution, and you're going to click on Normal. Analysis, Probability, and the Normal. You click those 3. And you should get this window. Okay. Now, our goal is to figure out the area that we shaded in green. So you're going to utilize this first box. I will tell you later what to do on the second box, but to find the area shaded, you enter your number that they provided you with in the column. So the number was 0.44, right? So you put your 0.44, you hit evaluate, and you're going to get all this stuff here, right? The two main values that you want to just keep an eye on are these two numbers. You don't need this top part, these top two, or these bottom threes. You need these two for sure. All right. Now, recall when we shaded, which shade, what part did we shade? Did we shade to the left or to the right of 0.44? We shaded to the left. So that's going to be our answer. But you're going to have to round that number. So I'm going to write that number down. 0.67003. But the rule is when you get your area, you have to round it to 4 places behind the decimal. It has to have 4. 10 thousandths. 4 places you have to round. So you round your areas to 4 places. So my answer ends up being 0.6700. And so that's your answer. If you want to change it to a percentage, by all means, this ends up being 67%. So 67% of the curve is shaded. So less, remember, less means left area. Remember that. Less means, so anytime you see that inequality less than, you have to look at the left area. Okay. Let's do number 10. I'm gonna try to do one of each. All right, so number 10, how do I write the probability? All right, so I'm gonna write capital P, parentheses, Z is what? What's happening? What shading is occurring at negative 1.04? Is it being shaded to the left or to the right? We need the green area. That is correct. It's shading to the right, which means that it's going to be greater than. I'm going to put my greater than, and I'm going to write negative 1.04. So this is how my probability looks like. There it is. Here's my graph. Negative 1.04. I'm going to have to wing it. I'm going to just say it's right there. Negative. Negative is on the left of 0. Negative 1.04. And I'm shading to the right. And I have to find out the area that's shaded on the right of negative 1.04. Right? There's my greater than. My greater than. Greater than. Okay. So I'm going to go to my stat disk. And I'm going to enter negative 1.04. Now you gotta make sure that you enter the number and the sign correctly, people. You got to. All right. Again, you're ignoring the other ones except these two, but this time it's greater than. So greater than implies right. So my area, my probability is going to equal to 0.85083, and I have to remember to round to 4 places, so that equals to 0.8508. Screen. I can fully graph it. And if you want to write it as a percentage, 85.08%. So this is the shading. I didn't draw it accurately. It doesn't look like 85.08% of the graph has been shaded in, but yeah, I should have been a little bit more that way. But yeah, that's all right. So greater than means right area. Right? Less is left, greater than is right. In my notes on StatDisk that I provided you all so you can make copies of, right? It has it there too. Look, I have little arrows. Look, if you have P probability of Z less than A, you look at the left area. If it's greater than, it's the right. And it even tells you where to round it. So, just letting you know. In case you guys forget. Okay. All right. And now we got to do, we did less than, we did greater than. We have to do in between. Okay, so let's do an in between. I'm gonna go back to my book and let's do number 11. Number 11 reads, okay, now how do we write number 11 as a probability? Notice that the green region is between negative 0.84 and 1.28. So the proper way to write a probability with the in between is you write a capital P, parenthesis, and you start with the lower number, the number on the left. Negative 0.84 less than Z less than 1.28. So you put the smaller number on the right, the smaller number on the left of Z and the larger number on the right of the Z. So this is how you write a in between probability. Review. Here's in between. That's how you write it. You write it as a compound inequality. Smaller left, larger right. Graphically, how do you draw it? Right. Well, the first number is negative, so I'm going to just say it's about there. And 1.28, about there. More or less. Use your judgment. And you shade in between. Okay. So this time you want to identify the area in red that's between those two numbers. Now, in order for you to do it in StatDisk, you have to remember a particular song that Beyonce sang. You remember? Let's see, I'm gonna draw my little musical notes. You remember? To the left. To the left. I'm not gonna sing it, but you know the song. Anyways, that's the secret. So to calculate it or to have StatDisk calculated, here's what you do. You're gonna have to enter each of these two numbers into StatDisk, and you will have to find the left areas of each of those. But you have to start with the larger number, the one on the right. Always start with the, so you're gonna find the area, find the left area of 1.28 first, and then you're going to subtract the area of the left area of the small number, negative 0.84. So there's where the to the left, right? No, to the left, correct. To the left. So you gotta each one you have to look up into StatDisk and find its left area. Okay, so let's look at it. So let's plug it in, and I'll tell you why in a little bit. Why do you do that? Why do we do that? Okay, so I'm gonna put the bigger number first. I'm gonna put positive 1.28, and I'm gonna get the left. Now I got the sum in my head. And you all can either leave the decimals as they are first, subtract it, and then round, or you can round it and then do the subtraction. It does play a little factor on it. It'll be off by 1,000 if you do it one way or the other, and that's fine. I'm just gonna leave it as it is, and then I'm gonna look up both numbers. I'm not gonna round them yet. 89973 is the left area for 1.28, and then I gotta calculate the negative 0.84, and I want to get the left area again, to the left, and I'm not going to round it. 0.20045. I got my two answers, my two numbers, and I'm going to subtract, which what I do in the calculator, I had it. So 0.89973 minus 0.20045. I end up getting 0.69928, which then rounds to 0.6993. Or you all prefer to write it as a percentage, 69.93%. There's my answer. So that's how you do it in between. You gotta look up both of these numbers each individually in StatDisk, and you gotta get the left areas, hence the Beyonce song, and then subtract them. Now, why do you subtract them? Okay, so the reason why you subtract them is because when you look up the 1.28 and you're looking up the left area, like you're getting this line and you're shading all of it from that point all the way down to the very end of the graph. Okay, that's the 1.28. The negative 0.84, this is this part. So what you're doing is you're getting the blue part, all this blue part, and you're taking away that piece. So that way you're left with this part. That's why you subtract. This is the bigger side. This is all that part. And this part is this little end part. So you're taking this part away from that part. And that'll leave you with the middle part. Right. So someone's asking me, sure, what happens if I accidentally wrote this number first and then I subtracted that number first? Well, let's see what happens. What would happen if you accidentally, here's my little thinking cloud. I'm not gonna do this now. Anyways, what if I accidentally did 0.20045 and I subtracted 0.89973. Well, if I did that, I end up getting negative 0.69928. Weird, huh? What happens if I get a negative? Sir, what happens? Well, look, they're the same numbers, but one's negative. So to fix it, all you have to do is take off the negatives. Areas cannot be negative values. I'm putting little stars in case that happens and you forget to do the bigger number first and then the smaller number last. You just take out the negatives. There you go. All right, so we did each of those. All right, and you all can do the rest for the homeworks. So for the homeworks, you would have to do 17 through 36. Again, you're going to have to write those in probability format. You have to write capital P parentheses and then the symbol, and it tells you the symbol what you're going to put less than, and then the number follows it. You'll have to draw them and then find the probabilities. So there's only 3 of them. There's the less than, there's the greater than, and the in between. And yes, the in betweens always, they always go like this. Less, less. Okay, you will never have ones that go greater, greater. It's always less, less. That's the rule. So those are the only 3 that we have: greater than, less than, in between. So you will have to write for 17 to 36. You will have to write them in this format, the probability with parentheses, right? You'll have to draw the picture and then find the area. Okay, very simple. Very simple. All right, now the last part. So what we've done here, all these probabilities. We did probability of Z less than A. We did probability of Z greater than B. We did A less than Z less than B. All these were finding the area under the curve given a Z value. That's what we just did. We finding the area under the curve given a Z value. That's what that is. Okay. Now we can go backwards. What if we were given the area and I want to trace it back to the Z value where it came from? You're like, what? All right, let me show you a picture. What if you were told what the area was? Let's say that the mark was here. Like that. And you were told that this was 45.67%. You were told that. And they're asking you, what is Z? Question mark, question mark, question mark. What is Z? So these are different. This is given an area, find the Z value. This one's different. So recall that when we went to StatDisk, we entered our Z value in this window, right? The second window is what we're going to be using now. We're going to be given an area, but notice what it says. It says you want the area on the left side. So in order for us to find the Z value, here's a rule. The rule is the area of the left side of curve must always be known. Known. It should always be known in order for you to plug in that number in that box. If you don't know what the left side is, we'll have to do a trick. Okay, so let me show you what I'm talking about. So on your homework, let's find it. They are problems like 13, 14, 15, 16. So let's look at number 13. Oh, before I do that, write these notes down. Blurry. There you go. So we're going to be given an area. We're going to find the z-score. We're going to go backwards. So let's say that this is 45.67%. I want to find the z-score where that came from. So the rule is the area of the left side of the curve must always be known. This side, it's got to be shaded all the time, and we got to know that side. If this is given, if the right side's given, we still need to figure out the left side. Okay? So let's do 13. 13. Let's say we're okay on 13. Is the graph shaded on the left of the curve for number 13? Let's see. Let's see. Okay, yes, it is. That Z mark on number 13 from that point is shaded to the left. Yes, it is. So you're going to get this number and you're going to type it into StatDisk on the second window. On the second one. Now, I have it on my notes, on the StatDisk notes on your paper. If you scroll down on page 3 in the handout, it tells you where to plug it in. See, it says here, there's the area, and it says it there, cumulative area from the left. You're going to plug it in right there. And the Z value will be this top number at the very top of the right window. It'll be right there. There's your Z value. And it says do not round. Don't round it. All right, so let's plug it in. Let's go to StatDisk. I forgot what the number was. 8907. Okay, so we're going to go to StatDisk, and I'm going to enter 0.8907. I'm going to hit evaluate, and presto, there's your Z value. Okay, so I'm drawing the picture. Hold on. I'm drawing the picture. You can see that I am not making things up. $89.07 on it. Lock and see what I have. Let me just write down the number. 1.23026. Okay, now you can see. There's my answer. Boom. Simple. And you just copy down. There you go. Done. All right. 14. Let's look at 14. 14. All right. Okay, so no, oh, they did put a 0. Look at that, they put the 0. And the Z is on the left side. Ooh, what does that tell you about the Z? What kind of sign is the Z value going to be? If it's on the left of 0, it has to be a negative. All right, so the shading is taking place, right, to the left of that Z mark. So that means we're good. We can do it. We can do it. It is 0.3050. So I'm going to enter 0.3050 into stat disk. You gotta make sure that that area is in decimal format. I forgot to tell y'all too. And so I'm gonna put 3050, 3050, enter. There's my Z value. Negative, just like we thought. Negative 0.51007. There's my answer. Simple and swift. Okay. Okay. As long as the left side is shaded, we're good. All right, now comes a problem. Let's do number 15. Notice on 15 we have a problem. Houston, we have a problem. Let's look at 15. 15. Notice on 15, the shading is taking place on the right of Z. Uh-oh, we can't do it. Or can we? All right, so again, notice the position of where Z is at. Z is where to 0? It is on the left. So that means the Z value is going to be negative, correct? All right, what was that? Oh, 9265. 9265. 0.9265. Okay, so here's what you do. Because the shading is taking place on the right side, I need to know the left side. That's important. I need to know this side. I know this one. I need this. How do I figure out this side? Okay, well, recall probabilities. Remember the complements? Well, this red is the complement of that one. Do you remember how to find the complement? That's correct. We subtract that from 1. So we have to do 1 minus 0.9265. And this will tell us what the red area is. And so happens to equal to, take on my calculator, 1 minus 0.9265. This is equal to 0.0735. And so I am going to enter that number, not the green one, that's the right side. I need the left side. I need to enter this number in StatDisk, and that'll give me the proper Z. So remember, it's going to be negative. All right, let's see if it's correct. If I do enter a negative, all right, let's see, it's going to be a negative. Let's see. I'll go to StatDisk. I'm going to put 0.0735. And sure enough, look at that. Look at that. It is negative 1.45021. Okay, now that's how you would do it the long way. There's a shortcut. Okay. So here's the graph. So given the right side, I have to figure out the left side because that's the only way I can use it in StatDisk. I have to enter the left side. So I subtracted that from 1 to figure out this side. And you can double check. This plus this equals 1. I need this side. And notice that it comes out to be negative. Now here's a shortcut. Did you know that if you enter this number in StatDisk, let's see what happens if you forgot how to do the subtraction, right? And I enter 0.9265 on that second window. Let's see what happens. let's put 0.9265. Notice that your z value is the same number, but positive. Interesting. But is it consistent with the graph? The numbers are correct, but is it consistent? That's positive. That's a positive number. Well, if it was correct, the z would have been over here, but it's over here. So do I just change it to a negative? Yes, that's all you do. You enter. If you know the right side, just make sure that you change the sign of your z value and you're good. So shortcut. If given the right area of curves, look up in StatDisk and change the final answer, change the sign. Change the sign. I got too excited. The sign of the final answer to the z value. And let's see if it works. Just let's just see if it works. Let's do 16 and see if the shortcut works. Okay, so if you look at 16, which area is shaded? Is it shaded on the left or the right of the z? Let's check it out. It's shaded to the right. I'm gonna look it up. I'm just gonna type it in. Why not? Let's type it in. I just gotta remember, if it's on the right, I gotta look it up and then change the sign. All right, so what was the number? 0.2061. I gotta remember to change the sign. Okay, I'm gonna look up 2061. I'm around in 2061. 0.2061. It's negative, so I got to change it to a positive. So my answer is 0.8 positive 0.82003. There's my answer. You guys can double check. If you don't believe me, you don't believe that this rule, this shortcut works, you can always find the left side. You can find that. So if I do 1 minus 0.2061, you will see that you get 1 minus 0.2061, and you get 7939, which is that area. That's what that area is. You look up that number, you should get this number. Let's see if it works. 7939. It's supposed to be a 9. Let's see if it works. $82,003. Bam! I just dropped the mic. There you go. Same thing. Bam. But it was quicker just by looking up that number and changing the sign. So that's the shortcut. If you're given the right area, not the left, the right, look up the value, change the sign.